Hi, everyone. My name is Ben Lakoff with Charged Particles. A little bit later, you'll hear from Rob Secord, and we're really excited to tell you all about Charged Particles today. So we'll start off by going over a little bit about what is Charged Particles. So it's a protocol and a DApp. So I'll explain a little bit about those. We'll talk about the roadmap, where we're going, the team, some of the investors behind it. And then I'll switch and do a quick demo of the DApp. So what we have built thus far and kind of flexing the creative muscles that you may see there. And then later, Rob will join and do a little bit more detail on the protocol docs and the technical specs on building with charged particles. So the charged particles protocol allows users to deposit tokens. So this can be any sort of ERC20 tokens, speculative tokens, LP tokens, yield-bearing assets tokens, or NFTs into their NFTs. So we give each NFT a smart wallet that enables it to hold these other assets. Charged Particle is NFT agnostic. So there's tons of different types of NFTs out there. We will be able to service all of them. And the real beauty here is it allows custom token mechanics around the principal and, if applicable, the accrued interest of those underlying tokens. So your NFT now is a container or a basket that's able to hold other assets. Some of these assets may be able to earn interest. So we have an integration with Aave and Compound. So the assets that are owned by this NFT inside of this NFT can be accruing interest. So this accrued interest is completely configurable and gives you a lot of flexibility with what you're able to do with this new token mechanic. So our crypto art DApp is live, went live 17th of February after a lot of development, and the protocol is also live. So our DApp, this is targeted toward crypto art, and it allows crypto artists to do more with their NFTs. So imagine a artist that has a social token. You can now very easily create these NFTs, these scarce, rare pieces of NFT art, and you can fill them full of your social tokens. These social tokens that you put inside of your NFT, you can time lock. So you could fill it full of 1,000 bin tokens and time lock those tokens for a year. So you could buy this piece of art filled with 1,000 bin tokens. It has those bin tokens inside of it, but I can't pull them out for a year. Alternatively, you could fill it with 10,000 DAI, which is converted to a DAI and starts earning interest through the Aave protocol. This interest is programmable, so a portion could go back to me, the creator, into perpetuity, like an artist royalty. A portion could go to another wallet, an external wallet, like a charity. And it really gives you this flexibility of doing a lot more, being a lot more creative with these already very creative pieces of art. So you have a lot of customizable token mechanics. What type of tokens are going in? Are they time locked? If it's interest bearing, where does that interest go? We do have support for all ERC20 tokens. So BEN tokens, WBTC, any sort of token you want can be deposited into your NFT. Any sort of yield assets that are supported by Aave's A tokens, we support those. We do have an integration with Compound C tokens as well, and we'll be looking to add additional liquidity providers as well. And all of this interest, if there is an interest-bearing aspect to the tokens that you're putting inside, is completely programmable. So a portion can go back to the artist, the creator, a charity, wherever you want. You're in charge here. So it's important to note that the NFTs created on the Charged Particles protocol are standard ERC 721s, non-custodial, fully transferable NFTs. You can sell them again on OpenSea. It just gives it this additional functionality, this smart wallet that enables it to hold other tokens, other assets. It's important to keep in mind that Charged Particles is a protocol. So the DApp is targeted toward crypto art, but at the protocol level, this is where you can get very, very creative. So as you know, there are a lot of different types of NFTs. Crypto art is one tiny segment. And really, all NFTs can be charged and hold a token and hold an interest-bearing token. And the customizable configurations of what to do, this token, this NFT basket that's holding these other assets that are accumulating interest, what does that mean for that NFT? Does it unlock something new, something special? So you think about all of the other NFT categories, for instance. So in some of our docs, we talk about in-game items. So a sword represented as an NFT. Well, you deposit $100 into this sword, so now it's got a intrinsic value of $100. It's basically a piggy bank carrying that $100. But thanks to DeFi and these yield opportunities, that $100 is converted to 100 ADAI and starts accumulating interest within that sword. So imagine a game where the sword that you have, the accumulated interest, which is a byproduct of time and the amount you've put in, represents the amount of power that sword, that in-game item has in the game. So then you can imagine all sorts of crazy things. So I have a sword that has some interest. You have a sword that has some interest. We battle, and the winner gets discharge, gets that accumulated interest. So it gives you a lot of these really, really fun possibilities. We're really bullish on NFTs in general, but I think there's a couple billion-dollar ideas hidden within this protocol, something with financial use cases. So you think a bond being represented as an NFT with the collateral locked inside. It's a very good use case. I don't know about the regulatory aspects of this, but this is why hackathons are very fun, right? It's basically a regulatory sandbox, and you're just focusing on innovation and innovative use cases for the protocol. We have a lot of ideas. So in our docs, we have hackathon ideas, we have possibilities with charged particles, but it really gives you a lot of flexibility. The building blocks are your NFT is now a container or a basket that can hold other assets. It can hold other ERC20 tokens. This can be LP tokens. This can be speculative tokens. This can be interest-bearing tokens. And this interest adds this whole new mechanic of your NFT is now has this interest accumulating inside of it. So gives you a lot of flexibility. And I definitely want to see virtual geocaching where you hide an NFT and it's accumulating charge. The person that finds it is able to discharge the accumulated interest, and then you hide it again. Very easy use case, totally possible. Bullish on the metaverse. I want to do a virtual geocaching scavenger hunt and find some accumulated interest. That's for sure. Governance tokens. So at Charged Particles, we believe in progressive decentralization. Eventually, we will have a governance token. We'll release this governance token sometime in the future, and the majority of this token will be distributed to the community via liquidity mining programs. We're talking through a ton of these now, but the idea of liquidity mining within your NFTs, and we actually have this Lepton, which is a yield multiplier NFT. So you deposit this NFT into the NFT that you're liquidity mining, and you get a yield boost. So a very, very interesting way and unique way of integrating the tech into these liquidity mining programs to help distribute our governance token to the community when it goes live. Wanted to put this roadmap in. So it's important to note that we've been working on this, thinking about this for a while. So DeFi NFT is our Twitter, which was tagged in February of 2020, far before this DeFi NFT wave that's happening right now. But Rob Secord actually started thinking about charged particles in late 2019 at some of these hackathons, and actually had a proof of concept in early 2020. Rob and I met in the Gitcoin kernel accelerator. So this is a Web3 accelerator. Highly recommended you check it out if you haven't heard of it before. They're opening up for the third cohort here soon. Great group of people. That's where Rob and I met, and we really solidified a lot of the ideas around charged particles. And we decided to go full-time on charged particles in October and closed a funding round in, announced in February, when right before we launched to mainnet. And we're going at this point. It's really, really exciting, as you can imagine. The team, so Rob and I, so you'll hear from Rob later. We have 2 full-time devs, so Sam, Casey, and Eric. They'll be in the chats, always responsive in these hackathons, really trying to help out lend a hand. Mango, he's our community manager. He's also in the chats, trying to wrangle in some team members to get you guys excited about building on charged particles. We have 2 advisors on the team officially, Travis Blaine, who's DeFi Dad, maybe you know him from Twitter, and Leighton Cusack, who is the co-founder and CEO of Pool Together. If you haven't checked out Pool Together, check it out. No, I'm not allowed to say a no-loss lottery, but it's really, really cool. And I can't wait to see some of the cool innovations of charged particles and Pool Together. That's for sure. Wanted to throw this slide in here as well. So we did close a funding round in February, or announced it in February. So it was led by the Lao, and we had people like CoinGecko Ventures, Parify, and some really good angels join as well. So in summary, we're really bullish on DeFi. You almost have to be at this point. It's a ton and ton of really good innovation happening there. NFTs, obviously very, very bullish on this as well. It's a little frothy within the art market perhaps right now, but NFTs are much broader, and we're just really scratching the surface of the potential of these things. So the ultimate vision is when somebody interacts with an NFT, they will need to ask, does it have a charge? Does it have some sort of asset inside of it? So I am going to switch. So if you go to app.charge.fi, you'll be able to see our DApp that's live. When you arrive here, you'll log into MetaMask, and you'll notice that it's a minting station. You're able to create NFTs. Pretty similar to most minting stations. We don't charge any fees with this. You can come upload your JPEG PNG and turn this JPEG into an NFT. One unique aspect here is creator royalties. So a percentage of the interest can always go back to the creator, and a percentage of the resale. So if I sell it first for $100 and the second sale is for $1,000, I'll get a percentage of that bump up from $100 to $1,000, which is a quite cool feature here. So this is the minting station. We also have a marketplace. So these would be charged particles that have been minted on our platform. If they have a little icon, and we're actually redoing this right now, so it'll look a lot cooler here in the next week or so. If they have a little icon, you'll know that there's these tokens have a charge. They have some asset inside of it. So for instance, this one, and we just had an event yesterday. So there was a lot of fun tokens being deposited into these NFTs. So this is a normal NFT. It's being sold for 4 ETH. I can purchase it right here. But then I'll notice that there is actually there are tokens inside of it. So I'm not actually sure what AMM DAI is, but it's earning a little interest. It has some charge accumulated already. This is how the marketplace works. We actually curate this now. So this is down the line. We do want our governance token to be a part of curated lists for the marketplace. So the based on the amount of tokens you hold or stake, you can kind of choose the art that goes up on the marketplace. But for right now, we're curating it if you have an art piece that you would like to see featured, just message us and we'll throw it up here maybe. The other thing you'll see here is leptons. So these are the yield multiplier NFTs that I mentioned before. You take this lepton, deposit it into an NFT that you are yield farming, and this will give you a yield farming multiplied reward. So once you've created a charged particle or you have purchased a charged particle, you're able to go in. This is what your NFT will look like. So you have the opportunity. Oh, AMM DAI is just DAI. It's got a weird name right now in the UI. You're able to energize. So you're able to deposit tokens inside of this. So you're able to time lock. Actually, release is the principal plus the accumulated interest, or discharge would just be the accumulated interest or the charge. I'm also able to time lock it. So this asset, this amount that is inside of the NFT in the NFT smart wallet, I can put a time lock on it so nobody can pull it out until after that time lock expires, and then obviously set price. So these are kind of the pieces of charged particles, the DApp. Okay, so the last thing I wanted to share were our docs. So if you go to docs.charge.fi, you can go down here to Hackathon Ideas. We've thrown in a few of the ideas that people have been spitballing around. If you join our Discord channel in the hackathon, there's a lot of people that are looking for teams or have ideas that want to build using charged particles. So one that just came up yesterday, this was actually from Sam, somebody on our team, and we've already put together a little group on it, is this goal-based savings account. So picture an NFT representing, so the NFT is like a hazy picture of a car. So as you're putting more assets inside of this, more principal, and it's accumulating more interest, more charge, this picture of the hazy car starts to get a little bit more clear. So it's a very visual learning saving for perhaps for children or somebody a little bit younger. The more money they put in, the more time elapse, that the more interest that earns, the more that picture of the car is getting a little more clear and a little more feasible. So these are just some of the ideas that we've come up. But jump in our Discord. A lot of our team will be there participating, helping out, answering questions. We have a lot of really good ideas. There's a lot here. I'm going to hand over to Rob, who's going to talk in a little bit more detail the technical specs on building with charged particles. But we're really, really excited to be here and really excited to see the innovation that comes from NFTHack. Cheers, guys. My name's Ben Lakoff. I'll be in the chats. Really excited to be here. Thanks.
All right. Hello, everyone. My name is Rob Secord. I'm the founder and the principal engineer of Charged Particles, and I'd like to just take a moment to welcome you guys to our quick little video. I don't want to take too much of your time. I know how much you guys love watching these videos, so let's just get right into it and get you guys hacking. I'll take a quick brief overview of the documentation site that we have, and then I want to give you a brief overview of the contracts and subgraph that will allow you to integrate with our product, with our protocol. So I'm just going to share my screen here. We'll jump right into the little presentation. So to begin with, our technical documentation, it's all available on docs.charge.fi. It's the central place to be for anything related to our protocol and when you're developing on our protocol with our API. What you might find there, to start with, we have a lot of guides on what charged particles is and how everything works. But you'll also find a lot of resources, such as our GitHub repository links to the contracts and to the subgraph. There's contract addresses listed there for mainnet and Kovan, the subgraph playground. There's some reference material. There's some media and press kit material, logos, images, stuff like that. And there's also a glossary of terms for the charged particles universe. A lot of our terminology is based around the standard model of physics, so it's probably a good little bit of reading if you are not familiar with that. Once again, the main place to be, docs.charge.fi. So just remember that address and you should be good to go. And if you ever find yourself with any difficulties, just remember you can always reach out to us on the ETH Global channel on the Discord server. We have a private channel for charged particles on there, as well as you can always reach out to us on our main Discord server for charged particles. All right, so let's get into technical specs. Some of the stuff for the Solidity contracts that I want to mention right away, I'll try to be quick about. These are the main things you're going to want to use when integrating your application or your project with charged particles. So the main thing is mass and charge. The mass is the principal of the deposits that you put inside of your NFT. We consider that the mass. So the more deposits you have in your NFT, the kind of like the bigger your particle is. And then as interest accrue on those deposits, that interest is considered to be the charge. So the more charge your particle has built up. So of those two ideas, you can charge up your NFT and you can discharge your NFT and you can release everything from your NFT. And what we mean by that, when you energize, you're adding mass to the particle. So you're depositing assets into your particle. And we have two different rails for that. You can go through an Aave integration, and when you do so, your assets are automatically converted into an Aave interest-bearing asset, and your particle automatically starts generating charge. Or you can choose to go through a generic ERC20 rail, which will allow you to basically deposit any ERC20 into your NFT, but it won't necessarily generate a charge because most most ERC20s don't necessarily generate an interest based on a deposit. Once you have the mass in your NFT and is generating a charge, the owner of the NFT can discharge the particle, meaning they can remove some or all of the interest of that particle. You can choose to remove by amount, or you can just remove all of the charge. So that just means the mass will stay in your particle, but all of the interest will be removed. And then because there's still a mass in your particle, it will continue to generate interest over time still. It can also be discharged by the creator. And one of the nice features of charged particles is that we allow the creator to earn a portion of the interest in the NFTs that they create. And by doing so, of course, the creator can always come by later to their NFTs that they've created, even if they don't own them, and discharge that creator portion that is reserved for them. And then there's the release functionality. When you release, you're removing the mass and the charge. So you're going to pull out the interest portion and the deposit portion from the particle. And you can do this again by a specific amount, or you can just take it all out and leave the NFT empty for that specific asset type. When you integrate with charged particles, there's some certain settings that you'll be able to configure. If you've created your own NFT contract and you want to integrate your NFTs with charged particles, meaning you want your NFTs to be charged up with different types of assets, whether they're yield bearing or not, you can do so, and you can set requirements on your NFTs. So you can set specific requirements for the provider. For example, maybe only Aave is allowed to be selected, or maybe only the generic ERC20 types, or maybe only Compound in the future when we have an integration with Compound. And then you can also specify the exact asset type. So maybe it's only DAI or only USDC that you can deposit, as well as min and max deposits. There's a few settings you can set to allow your NFT to be charged up under your rules. Again, if you are going to integrate your own NFT contract, make sure you share your NFT contract with us in order to be included into the universe, so that our system recognizes your NFT contract and will then be supported. And another thing, when you do create your own NFT contracts, you want to support creators. And in order to do that, you want to basically expose a really simple creator of function. Most NFTs have an owner of, a balance of, so you might be familiar with these types of exposed functionalities already. So you just need to track in your NFT contract who created the NFT, and just expose a creator of function that takes a token ID, returns an address. And you can see an example of all this in our contracts for the Proton. Our Proton contract has a good example of that. We also allow the NFT creator to set the percentage of the interest that will be reserved for them. So it could be 5%, it could be 15%. So as interest generates in your particle and you start generating a charge, the owner will get the bulk of that, the majority portion of that interest, but a small percentage can be reserved for the creator. And the creator can even redirect where they want that interest to go. So the interest could go to an external receiver address, which might be a treasury, an escrow, a loved one, a charity perhaps. Maybe you want to pass it down through the ages and have your children inherit it. There can always be a constant interest revenue stream for the artwork that you've created or for the NFTs that you've created. All right. Beyond just the creator of the NFT or the creator of the NFT contract, the owner of the NFT has a lot of settings that they can choose as well. Just like any NFT, you can manage approvals for your NFT, but this goes a little further than just transfer approvals. So we have discharge approvals, release approvals, and time lock approvals. So you can allow a third party to manage your token for you, and they can choose to discharge it, whether that be a third party game. Maybe you're playing a peer-to-peer battle, and the game is allowed to discharge the user's or the loser's token to the winner. Time lock, maybe a third party needs to be able to time lock your token for a loan, for example. You can manage your time locks, whether it's a discharge time lock or a release time lock. If it's a discharge time lock, that means the token cannot be discharged or released until the time lock's expired. If it's a release time lock, that means the token cannot be released until the time lock is expired, but it can still be discharged. You can also manage restrictions on your NFTs, so you can decide whether or not, by default, any NFT can have assets deposited into it by anyone. And as the NFT owner, you can restrict that and say, no, only I'm allowed to deposit into my NFT. Excuse me. You're also allowed to set the rules for discharging and release. By default, nobody but the owner is allowed to discharge and release the particle. But maybe you want to change that. Maybe the particle is a geocached item, and whoever finds the item is allowed to discharge it, but not release the base principal assets. So that way, it continues to generate interest for the next person to come along and find it. And again, that person then can discharge the particle. As you develop on charged particles, you might feel that Aave or Compound or some of the other yield providers we have isn't enough for your needs. So you can always add extra asset providers or yield providers, and you can do this by looking at our contracts. Primarily two interfaces: the iWallet Manager interface and the iSmart Wallet interface. And your wallet manager would basically inherit from the wallet manager base and smart wallet based contracts. And again, there's code samples in our contracts code base. With a yield-based provider, you should manage the yield from the external liquidity provider and display that as a charge. From generic providers, of course, you just need to manage the asset, and there is no underlying charge because there's no underlying interest. There's a bunch of helper contracts in our library under the lib folder. And one particular contract that might be very helpful is the token info. And it's a lot of the mechanics used in our charged particles system. So if you want to get the unique ID of a token, the owner, the creator, the contract owner, the token creator, stuff like that, there's convenient functions in there to make your life a little simpler and make sure that you're integrating with charged particles in the same way that we do with our NFTs. There's other folders of note. There's the ABIs folder where you'll find all of the ABI files for all of our contracts. There's a deploy folder where you'll find the deploy scripts we use, which might be helpful when trying to figure out how the structure of the entire system works. The deploy files are a very good structured output of how we build up the entire universe. The deployments folder is output of all of our existing deployments, where you'll find contract addresses for various networks. And then there's the test folder, of course, for unit tests and integration tests, which might lend further assistance when trying to understand how the protocol works. Awesome. So we'll jump into the subgraph. We do have a hosted subgraph on the graph. The GitHub repo is on the docs. You can find it on the docs, but for quick reference, I have it listed here as well. We have one for mainnet and we have one for Kovan testnet as well. And if you want something for dev or for localhost, feel free to deploy your own. And if you need help, reach out to us for help. We're always happy to help. And then when you integrate charged particles with your DApp, all you need to do is add the subgraph. So you would import the subgraph, which brings with it all of the ABIs for all of the contracts, as well as all of the current addresses for those contracts for the various networks, whether it be mainnet or Kovan. Currently, the only testnet we support is Kovan. Again, that URL that you want to remember is docs.charge.fi. That's the central place for all of the information you're going to need to help build on our protocol. And also, if you need to reach out on the Discord, please do. Please feel free to find us, ask us any questions that you might need, and we will help direct you. For a quick reference of the GitHub URLs that I've referenced, this is the Solidity contracts. What you might want to look for is the interfaces that were pointed out. So these are the interfaces for the contracts. Take a quick reference, quick review of those. It will make you familiar with the API that we have exposed. We also have the subgraph. The subgraph is available here for your viewing. There's a test query that you can take right over to the playground and start playing with it immediately, and seeing what kind of queries you can generate from the data we've logged. And this is our documentation. So once you come in here, you can see how we interface with the protocol. There are links to the GitHub repository, the subgraph playground, and there's contract addresses, for the link to the contract addresses. You can also find those here under contracts, of course. We have the main ones listed here. And then there's just some documentation around a lot of the common functions you might want to use to integrate your project with charged particles. And that's pretty much it. Thank you for watching, and happy hacking.